Hello, welcome to today's section. Today we are going to talk about the data management. So I think you must be very excited because you have collected a large quantity of data. But before you have this large quantity of data, you need to be prepared yourself to tell yourself how to handle all this kind of data. So especially start from the collection. And before the data collection, you have to think about as you get this data and what you are going to do, for the data arrangement. So the first, for the data management, you need to arrange a space as needed for storing forms. For example, we usually to have many questionnaires, and there's many forms. So you may need a place, a bigger, a safe place to store all these forms. And also, when you get these questionnaire forms, you need to check the forms for each subject to ensure that they all are present. And then you write the code number for each forms. So otherwise, you will lose the forms. And then you keep all data from a single subject together. You cannot separate the forms from the single subject. Try to have these all forms in one subject, and you move it as a subject. And when you prepare the data for computer entry, first you need to download some software to do the data entry. So we do use several computer-based data analysis software. Usually in nursing research, these three are common. So the SPARS, SAS, and Stata. And I also listed the website for you. You can look through this website and you will see how to buy this software. Especially for students, they may have some student version, a little bit cheaper than the full version, but it's still okay for students to utilize. And then you need to make a rule for coding. That means before you enter the data, you do have design a coding book. And you kind of have a rule for each forms, for each questions, and how you code this question. Because when you enter the data into this kind of software, you do need enter the numbers. So that's why you need to have a coding book. And so before you do the computer, entry, the data, you need to be essentially automatic and require no decisions regarding the data. That means when you enter the data, you don't need to make any decision about this data I should enter or that data I shouldn't enter. You don't need to do that decision. That's the rule, because you need to be coded as it appears. So how the data showed in the forms, you do need exactly enter the data as it appears based on the coding book. And also sometimes you do have some reverse questions. Remember in the questionnaire, we talk about some question we may ask reversely. So you need to reverse coding. But at the first, you must enter all data, and later you reverse this kind of question, not reverse the coding at the first time. So remember, all the data at the first time, you just enter the original data. You don't need to do anything else. And then you need to correct the data before entry. For examples, we may have some missing data. You need to make a decision. If I have to use the number 9, or maybe 3 nines to represent the missing data in my database, or maybe you will use the mean substitution to represent the missing data. But usually for the missing data, there are several principles. First one is deletions, and second one is imputations, and third one is mixed modeling with longitudinal data size. I will give you an article talking about this missing data, replacement. So you will see how to deal with this missing data. But they do have some principles. You need to share which principle you want to follow. And then you need to think about if some question is single choice, but somebody, the subjects, just answered 2 responses, how you make decision, which one you are going to choose, or you are going to delete all of them. So you need to make agreement in your research group. And also some questions may be write down in the text with the text. So you need to make sure, are you going to code the text in, with some numbers, or you are going to, just enter the text in the database. And so when you enter the data, be sure you avoid distraction while enter the data. And you limit your data entry periods to 2-hour intervals. You cannot, work too long. Otherwise, you will lose your construction. You will be distracted by tired. You will be exhausted. You will be tired. So something wrong will happen when you enter the data. And then remember, that's very, very important. Back up the database after each data entry period. And then you store the database on a saved flash drive or secure website to make sure the data is safe, is stored very well. Usually I will store for 2 copies, maybe 3 copies. So in case some bad thing happen, you lost your data. And then the original data forms and the database must be stored for years, because regarding some funding sponsors requirements or some publishers requirement, usually we will save the data for 5 years. So try to, protect the data and save the data for 5 years. And then after you enter the data, you need to do the data verify and the data clean. These are 2 very important steps as well. For data verify, you need to compare. Maybe you can use your eyesight, because visually compare the numbers on printout of the data file with codes. So you just watch, you just look at if there's something wrong with the data. Or maybe you can use the double enter data. That means 2 persons will enter the data at the same time, and then you got 2 database, and you compare these 2 databases, and you will see if there are any difference happened. If something happened, something different happened, that means something wrong with the data entry. You need to go back to find out. And you need to do the data clean. So usually we'll do these 2 steps. First, you can track for outliers and wild codes, and then you can track for internal data consistency. So how to check for outliers and wild codes? What does the outliers mean? Outliers are values that lie outside the normal range. So outliers can be found by inspecting frequency distributions or paying special attention to the lowest and the highest values. And most researchers began data analysis by constructing frequency distributions for all variables in their data set. So for some researchers, such as me, I will then the frequency distributions and for all the data, for all variables, and see if their outliers existed. But pay more attention. Sometimes some outliers are true. For example, for some question about the income, somebody just fill out 1 million income, in a distribution. It might be true, and even though the mean is $50,000, but sometimes they result from data entry errors. So you need to make your own decision. And so what's the wild code? You need to check for outliers and wild codes. What's the wild code? Wild code is a code that is not possible. It's not possible. For example, there's one question in the questionnaire asking about the gender. So we code female as 1, male as 2, and missing data we just blank. But when you go through the data set, you found there is a 3 for the coding number, 3 for gender. That means something happened, some error happened. And the computer should show the ID number of the faulty record, and the correct code could then be tracked down. So it's very convenient if we have the dataset software, we can use that software to help us to correct. And later, for the data clean, the second part is check for internal data consistency. You need to check for errors by testing compatibility of data within a case. For example, there's 2 questions in one form. So the first one is ask the subject about their current marital status. And also second question is ask number of marriages. So if the data were internal consistent, respondents who answer single, never married. So to the first question. Then for the second question, he or she should write down as a 0 or missing values code. Otherwise, this is not the internal consistency. Something must be wrong. So just remember, when we do the data clean, we can use these 2 steps. So I will give you an example about data clean. So this article published in 2013 by Dr. Minsink and Norman, and they described something about their data clean. In their article, they said, after entry into a sparse data file, all data was subjected to test for outliers. We conducted more than 25 random checks of service retained by mail for data entry errors. So you will see how other researchers to deal with the data clean. So we talk about data management in this section. Just remember, before you do the data entry, you need to do the code. You need to have a rule of code. You do have a coding book, and then you enter the data. After you enter the data, you need to verify the data and do the data clean. So these 4 steps are very important steps for data management. So today we'll talk about this and see you next time. Thank you.